Welcome to Lesson 7, example number 7, and it is asking us to do three things. It says, what load can be safely resisted by the connection using 1. ASTM A325 bolts slip critical connection. So I guess I can go ahead and write this. Whoops. Let's do it in pink, what we need. Don't use pink too often. 1. Slip critical. 2. It says ASTM 325 volts bearing type connection. Bearing type. And then number 3, it asks us ASTM 325 bolts bearing type connection, threads excluded from shear plane. Oh wait, I have to say bearing type threads excluded, and this is 3 threads. I hope this makes sense when I say 3 threads. For instance, let's do, obviously this is, let's say it's a hex head bolt. It comes down here, and you have a certain length that doesn't have threads, and then you'll come down. Whoops, that kind of got a little out of control. Alright, and for instance, obviously this is not perfect. So this is assuming through thread is meaning if you have like here's one piece of metal that you're connecting, and here's the other plate, and in your shear plane it's cutting through the threads. So your diameter of that metal is actually thinner because of the threads. And then threads excluded, meaning if you had two smaller. Obviously these aren't the perfect drawings, but I'm just trying to give you a sense of, here is the shear plane, would be right here, and therefore it's this threads, it's not where a thread is, so you're going to have a better, more of that metal to resist it. Alright, let's move to a different color here. Okay, so let's go ahead. Slip critical connection. 1. Slip critical. And the easiest, these are framed beams. And knowing this, the easiest way to go about this, they have some tables that are set up to help you with this type of setup. So you want to go to page 4-20. And you really could do all this by hand, and you could go to the specifications section, and you could figure out all the shear, all the the pull-out stuff, all the things that you need to figure out. Go through all the specifications, and you can come up, do this kind of by hand, but they've given you some tools in this book to help you out. And they have these frame beam connections, and you want to look and see which table you would like to use. So let me see if I missed a. Alright. So it looks like I have on 4-19 it is slip critical, and then on 420 it is bearing type with standard or slotted holes, and then 21 is slip critical connections with oversized short slotted or long slotted holes. Alright, so the big thing is you need to figure out which table you would like to use. And we are going to use the table on page 4-19 because it's a A325 bolt and slip critical connection with standard holes. Alright, so what we do is we want to say bolt type, we have A325. Do we? Did it say that? No, I believe it did. Yes. STM A325 bolts using slip critical connection. So we want to do go to A325, and SC means slip critical. You can see it gives us the shear stress, 17. And then we go down, and we have bolt diameter as 3/4 of an inch. And we go down. And on the left, you see angle thickness. And we had, what were our angle thickness? And it might not be, we do have a 14.5 inch angle. You could take it from there, but I would probably rather go ahead and say, hey, look, I have N equals 5. That means you need 5 volts. And then you go over and you see both 14.5 and N equals 5 is what we both have. And you go over and down from 3/4 and you get 75.1. 75.1. And that's your allowable, I guess, shearing, I would say. It depends how you want to look at it, but I would call it, it's a shear. It's coming down like that. So it's you call it a reaction, I guess. Depends how you want to look at it. All right, and that's not per bolt. That's for all 5, because remember we had N equals 5. So that is for all 5 volts. And that's our slip critical. So assuming that's how much it can handle before it theoretically would slip, according to what we're doing right here. So if it does slip, you want to go ahead and check your bearing, just in case it does slip, which the allowable bearing value per bolt equals your web thickness, which is, let's think, which web do we want to use? And it's going to be, as you can see, where it's going to control is going to be this W21/62, because it only bears once right there, but it's bearing twice over here, and that's probably a thicker web. And then you have 2 angles. So let's go look up the thickness, the web thickness of a W21/62. And I'm going to W shapes, and I am on page 1-20, and we go over W21 by, what I say, 62. I go over to TW, and it's 0.4. So that's your web thickness times your bolt diameter, which is 3/4 of an inch, times 1.2, and then it's your FU, which is 58 KSI. Now remember, you can find this FU, what it's supposed to be, go to page 4-3 in your connections part 4 section, which it does get a little confusing going back from connections to specifications and whatnot, but once again, just get to know those sections. Understand that there's kind of 2 sections per combination or tension. You have combined bending, and we have column section is part 3, but then you also have a specification and code section that deals with columns. So it gets a little bit confusing. Just know that steelbook and how it's set out, and it should get you to a point where you can handle it either way. Alright, so that is that. Let's go ahead and remember, this is our how much that this can handle. And we're going to get 0.4 times 0.75, 1.2 times 58. And we get 20.9, let's say. And then we have 5 bolts equals 104.4. Alright, so this is larger, so this controls, which as far as I know, typically always. I never like using that always term, but most time this will control. So here's your answer for slip critical. Let's move on to bearing type. Through thread. And we once again want to go back to those frame beam connections tables. And this time I don't want to be on 419, I want to be on 420, I believe. And it says for bolts and bearing type connections with standard holes. Standard or slotted holes. And that's what we have. So we now want to go down and do the same exact thing. We want to say that, let me think. This is what? Through thread? Yes. And if you remember, N is for through thread and X is for threads excluded. So we want to first do threads are through thread. So we want to go A325N, go down 3/4. I'm going to try to go a little bit faster here. Then we want to go same thing, 5, 14.5. We have 92.8 kips. Remember, that's for all the bolts. Remember, we want to check it with bearing as well. So we know that the bolts are okay. This is for the bolts. Now we want to see if the plate, or in this case the girder web, is okay. And once again, it's the same thing. It's this 104.4. And it's less than that, so this will once again control over that. And that is your answer, I guess. I don't need to go any further. I think I was just waiting for something else to say, but no need to. That's your answer for number 2. Now we want to go on to number 3. And number 3 is that same table that we were just on. Go back to it. And it's A325X. So we want to go down and go to 3/4. Go down, go over 5, and you get 133. Remember, this is for all 5 of them. 5 of them. So the bolts right here can handle 133 kips. But as we know, how much can the web handle? Well, we said it was 144. So this does not control. So I'll just put DNC, does not control. And for this, now that might be confusing because I'm using that 104 a few times. If you wanted to have a clean set of calcs, you could do this where you do this every single time. You just say bolts allowable, allowable shear, we could call it, equals 75.1, and then bearing allowable equals 104.4, and you say, oh, okay, well, the smaller allowable controls, you could do the same thing down here and do it again, 104.4, and then down here you could do it one more time, 104.4 controls, and you could say it does not control because it's greater than 104.4 kips, and then I don't know if you want to box it or something. So 104.4 kips is your answer for number 3. And I hope that makes sense, that these two, the bolts control, and on the third one, your W21x62 web controls. All right, I believe that's over. Let me take another look. 3, yes, that is your answer, and I guess that is the last example for section number 7. So I will see you on the lesson 7 quiz.